All right. So next, what we want to talk about is the actual logger shield. So we previously talked about all of the GPS stuff on it, but we now want to go over the SD card capabilities because it is a single piece of hardware that we're going to use. But it basically has two completely separate functionalities, the GPS and then the SD card. So, as we mentioned previously, that the GPS Shield has a slot for a micro SD card, and you can use that to store, your flight data on board in a non-volatile memory storage, so you can then read it out after you recover your payload. Specifically, the way that the Mega talks to the SD card is using the SPI protocol. So if you remember what we've talked about, there was the I2C or the I2C protocol for talking to devices when you guys interfaced to Arduinos and had them talk to each other. The GPS and your computer worked through the serial interface, also called a UART interface. And then this is the third type of digital communication protocol that you're really going to use on the Mega, and that's the SPI protocol. So there's no physical limitations to the size of the SD card you use on the Shield, but depending on which software library you use, you are only going to have access to different amounts of storage on that SD card for the reasons that we talked about, whether it's using 16 or 32, etc., bytes of storage space for the address. So the way that this works is when you slide the SD card shield into the slot here, it will only go in all the way one way, the correct way, so it's keyed, so you can't put it in upside down. And you'll push it all the way in, and you'll hear it click when it locks in. And that's important because you want to make sure you have proper contact, because if you're not contacting those pins, you're not actually going to be able to send any signals to the SD card, which means you're not going to be able to read or write to it. The way this works is very similar to like a Windows or any other laptop. You will save data in files, and then you will either read, or you'll read those files with the Arduino, or you'll just remove the SD card from the Shield, insert it into your laptop, and read the files in that way. So the first library that we're going to start everyone off with is the Adafruit SD card library. This is an older library, so we're going to have to manually download it, but we'll go through that during the activity. The reason that we want to use that library is it's a little bit simpler, and we found it's easier for people to use when starting out, but there is some limitations with it. So most notably, you will only be able to use 2 gigs of the SD card because it assumes that you're using FAT16 file system. Also, you must follow what's called the 8.3 format for naming your files, which is sort of the older file format where you couldn't have things like spaces and weird characters and super long file names. But we'll talk about that, exactly what that means, a little bit later. So, as I said, we communicate with the SD card over the SPI protocol. And that particular protocol requires 4 different lines. So the way that the SPI works is you have one master device and then multiple other devices that are called slave devices. So in this case, our Arduino is the master device. It is the thing that sends all the read and write commands, and the SD card is the slave device, and you could potentially have multiple slave devices all with one master device. You have 2 one-way lines of communication that you may hear referred to as MISO and MOSI, and that stands for master input, slave output. So that's the line that signals go from the slave device to the master device. And then the MOSI is master output, slave input, and that is where signals go from the master device to the slave device. And both of these are, if you remember back to the digital communication lecture, what we call a synchronous signal, as in there is a separate clock line that pulses at some regular rate, and the signals on those other 2 lines have to match up to this clock signal. And then finally, you have a chip select pin, which is how you select which of the potential multiple slave devices you're using. So if you have multiple slave devices, each of them would be on a separate chip select pin, and you would set that high or low depending on which one you're trying to talk to. For the Adafruit Shield, the chip select is set to pin 10, and on the Adafruit Shield, the MISO, MOSI, and clock pins are pins 12, 11, and 13, whereas the Mega assumes its default pins are pins 50, 51, and 52. But one thing that this library that we're going to use today basically allows us to declare what pins are, what each of these individual pins are in software, so that way we don't have to make like a jumper for the pins 50 through 52. Also, one thing to note, on the actual Mega, you have 6 pins that are in the very center of the Mega. Let me pull this up on the camera. Okay, so these central 6 pins, 4 of them are the same as 50 through 53 here, and that's designed so that you can, the idea being that you can connect SPI devices through these pins. And in fact, one thing you may want to do is you can get a little 6-pin version of the, similar to the rails on the outside, and that way you can put it in here, and then you can stack your shield on top. Right, and now my 6 pins come through here, and then I can potentially solder them to wherever I want to connect. And the important thing to note is, but on the Adafruit Shield, where we need to get those signals are these 4 pins over here, where you can see it says clock DI for digital input, DO for digital output, and chip select. But the library that we're going to use today will be able to just change in software that we're using there. But potentially one thing you could do is create a jumper similar to what we did with the GPS and run connections over to there. There's also some different shields that you could use that basically have the connection from these pins over to the SD card itself. So like I said, we're going to be using a library that will allow us to use the pins 10 through 13. And that way we don't have to make a jumper. So one thing I discussed earlier is that the file names have to follow this 8.3 format. And what that means is literally you have 8 characters, a period, and then the file extension. All that the file extension does is tell your computer what program it should use to open that file with. So usually you want to, in this case, because we're mostly going to be working with plain ASCII files, you want to use a .text, which is a text file, or a .csv, which is a comma-separated variable file that we'll talk about in a little bit. So 8 characters is the maximum number of characters you can use for the file name, but you don't have to have all 8. In general, you want your file names to give you some information. For example, you can encode the timestamp into your file name in some way. If you have multiple types of data in different files, you probably want them to be named a different way so that you can easily sort that information out. However, it's important to remember that you only want to be basically using letters, numbers, underscores, and dashes. You don't want things like spaces or periods because that can cause issues. So, like I said, the extension is what tells the computer what type of information is in this file and what program that you should use. So a text file is just a plain text. You'll usually open it in something in Notepad and you'll see just what is the individual ASCII characters. So on the left here, this is an example of opening a file in a text editor that's just a text file. But, you know, dealing with a plain text file in a text editor is not really a good way to do any sort of calculations on it. So what we want to do is, you know, write the file in a way that we can easily open it and do analysis on it. For example, we probably want to be able to make graphs or do calculations on it. So what we could do is write it in a way that we can just open it in Excel. The way you do this is usually with what's called a comma-separated values file. And all that means is that you have individual values, so like start, timestamp, altitude in this case, or the numbers down here, and then you have commas separating them. And what's nice about that is that will allow you to just open this file in Excel, and what Excel will automatically do is separate this into different cells. So each line in your text file will be a row in Excel, and then it'll break up the columns by the commas that you've used. So this is in fact the same exact file opened in a text editor and Excel on the right here. So you can see that it has, in this first column, you have whatever is before the first comma. In this case, it's all these start. And then you'll see the next column is a date, and then an altitude. But because you've formatted your file well, it automatically opens up into this nice, neat, formatted Excel file that you can then, make graphs of, do calculations, and save a copy of it as an actual Excel file. So how do we actually do operations with the SD card? Well, it's very similar to the way that we did our serial communications and we did our GPS operations. So the first thing that you have to do is you have to initialize your SD card object, and you're going to want to do this in the setup like we did with the GPS or the serial ports. And you, in fact, use a function with the same name. So it would be sd.begin, but in this case, you pass it 4 variables, and these are the pin numbers that you have for chip select, MOSI, MISO, and the clock. So then, like I said, you want to write in individual files. So once you have the SD card initialized, you then want to create a file object, which is going to be the software interface to the actual file on the SD card. And the way you do that is you call the open function on this SD card object, and you need to pass 2 different arguments to it. The first is the name of the file. So that would be like data.txt or whatever, but this should be a string of your file name following that 8.3 formatting. And then in this case, usually you'll pass this constant, which is why this is in capital. But what that's doing is telling the software that I want to open this file to write stuff into it. And then what that'll give you is it'll give you this file object. So that's why you have this equals my file. So then whenever I use the variable my file, that's telling the software, I want to do something with this particular file. And the way you do this is the same way that you print stuff to the serial monitor. You call my file. So where do I want to send this data? And then you can either use the print or the print line function. Usually you want to use the print line function, but depending on how you're building your string, you could just use the print function. So you pass this string of characters, and then those will get ready to get written to the file, but not necessarily immediately written. What actually happens is this string of characters gets sent to a buffer, and either if that buffer gets filled or you call one of these 2 other functions, then it does the actual operation that transmits the data to the SD card and writes it. So in general, you want to call this flush function right after you do your write, and what that does is forces that buffer to write the data to the SD card. That way you don't worry about, oh, I lost power before I could actually write it. And finally, the last thing you want to do is close the file, which basically frees up this my file object, lets you know that I'm done with the file for now. One thing to note is when you call this close, it will also do the same thing as this flush. So if there's any outstanding data to be written to the file, it will get written to the SD card when you call close. As far as whether to use print or print line, remember that the only difference between the two of those is when I call print line, it does the characters that you have in the function, and then it does a carriage return and new line character afterwards. So it'll write whatever is in this string, and then it'll start a new line. One other library that is a little bit more advanced, but would be what we recommend once you are comfortable with the initial Arduino SD library, is a library called SDFAT. And basically that allows you to use the full size of the SD card. You can use whatever file names you want. However, the way that it is set up by default, you have to use the hardware SPI pins 50, 51, 52. So you would either need to use the jumper, or there are ways around that, but that's a little bit more complicated. So if you want to do that, we can definitely help you with that, but at least for the initial learning, we're not going to use that library. And as usual, here is just some links for reference.